Hi, this is Lakshmi Tiwari. In this lesson, I'm going to teach you about complete text processing for beginners. So in this lesson, I'll be doing text processing from very basic to the advanced, where you can extract advanced feature from text data. The text data on which I'll be working is available on a Kaggle website. From there, you can directly download this data. And to download this data, you need to log in Kaggle. If you do not have account in Kaggle, you can create account in Kaggle, and once account is created, then this download link will be enabled, and it will download the zip file, and that zip file will be having this the data training the 1.6 million processed the data into a CSV format, and it has a 6 column. In those column, the 0 column is a target column, and the 6th column is a text data in which we are actually very much interested. And these are the Twitter ID, the tweet ID, and here is the user ID. Okay, so these are the data available. You can download it from here, and then you need to rename this data so that you can work along with my videos. I have renamed this data with the Twitter 16m.csv. So what you need to do, you need to rename this CSV file Twitter 16m and .csv. All right, essentially both files are same, just I have renamed this file to the Twitter 16m.csv. Now you need to put this the CSV file and this the Jupyter notebook in a same folder where you are working, and once it is done, then we are ready to work on this data. But before that, let me tell you that on which what are the things which we will be learning in this lesson. At some point, we will be also using a SPACY library. A SPACY is a very famous library for NLP, and if you are a very beginner for SPACY, then you can visit my channel KGP Talkie. At the KGP Talkie, I have made a very a lot of the videos on machine learning, and there is a playlist known as Natural Language Processing Tutorials, and it has total 13 videos. You can watch these videos where I have been working with NLTK, SPACY, and other tools of the NLP. And if you are interested into deep learning and other Python related tutorials, you can also visit the playlist to watch those videos. All right, let's come back to the lesson. And in this lesson, we will be learning general feature extraction, how we can load the file, and total number of word counts, character counts, average characters per word, stop words count, and count of hashtag and the mentions, and if there is numeric digits present in the tweets or not, uppercase word count, etc. And then we will be doing the another level of the processings and cleaning, in which we will be converting a Twitter data into lowercase. We will be also doing contraction to the expansion, emails removal and the count, as well as the URL removals and the counts. We will be also removing the RT, which is essentially the retweet, and we will be also doing the removal of special characters and multiple spaces, HTML tags, accented characters, stop words, etc. And then we will be also doing conversion of word into the base form of that word, because in a root verb it's always unique, but non-rooted word can be may have a spelling, okay, a different spelling, but the essential meaning is same. Like you can take the example like run. Run is root form, but run could be the runs, running, okay, and ran. So these will be converted into run. And common occurring words will be removed, because if words are occurring very frequently, then that means it do not have much meaning in the text data. And rare occurring words also do not have much meaning. And we will be also visualizing all the words into word cloud. Then we will be also doing spelling collections, tokenization, lemmatization, and detecting entities using NER, noun detections, language detections, sentence translations, and using inbuilt sentiment classifier, and advanced text pre-processing and feature extractions. In the advanced text pre-processing and feature extractions, we will be doing n-gram, bigram, etc. analysis, bag of words analysis, term frequency calculations, inverse document frequency calculations, which is essentially IDF. It's not TIDF. This should be actually IDF instead of the TFIDF. Let me correct this. Okay, so IDF, then we should have there the TFIDF by multiplying TF and the IDF, and then we will be also seeing how we can do the word embedding. Essentially, it is word to vector using spaCy. Once all these things are done, then we will be doing classification of these text using SGD classifier, logistic regressions, and logistic regression cross validations, linear SVMs, and random forest classifier. And in the finally, we will be doing the predictions on a data where we can find out the sentiments of the Twitter in between 0 and 4. All right. So this is the introduction, what we are going to cover in this lesson. Without wasting time, let's go ahead and start this lesson. So any machine learning lessons, before we start, these are the few libraries which we always import, like pandas and the numpy. So let's go ahead and import these pandas and the numpy. Since we will be also working with the spaCy, we are also going to import this spaCy. If you do not have a spaCy installed in your computer, you can download spaCy by running these 5 commands. So it will first download the spaCy, and then it will download the lookup data, and these are the spaCy. The libraries which is available into the small, medium, and the large format. So small is less than 10 megabyte, and MD is around 100 megabyte, and LG is around 1 gigabyte. So you need to see that which one you need. I'll be telling you in a different the part of this lesson which library you want, and then we will be using those. But in the meantime, you can put it in download so that it can be downloaded while we will be reaching to that section where we will be needing this library. Alright, so let's go ahead and read this file, twitter16m.csv, and this file contains 1.6 million Twitter data. Alright, so let's go ahead and read it into a data frame, which is a DF, and now we are going to see a few lines of DF which we can see by calling df.head. Now in this, you see here it has total how many? It has total 5 columns. Okay, total 5 columns, total 6 columns actually, and this 0 is target, which is sentiment. All right, now let's go ahead and we are going to get just 0 and 5, and that we can get like df is equal to df, and there we are going to get the 5, that's in first Twitter data, and then the sentiment. All right, and then I'm going to put here a column name. Okay, so here I have columns which I'm gonna put here. The first one is twits, and another one is sentiment. All right, so let's go ahead and see the head of this data. Now you can see head of this data, we have here a tweet columns and sentiment column. All right, perfect. Let's go ahead and get the sentiment values, value counts, which we can get with this one, df sentiment dot value counts. So in this we have seen that there are 80,000 rows which have sentiment 4 and 80,000 rows which have a sentiment 0. Now let's go ahead and see the mapping of this sentiment. Mapping of this sentiment is like this. We can create sent map is equal to like a dictionary, where 0 says that it is a negative sentence, negative sentiment, and 4 says that this is positive sentiment. All right, perfect. Now we are going to calculate now we are going to extract the feature, a general feature, one by one. So we'll be extracting word count, character count, average characters, etc. So let's go ahead and start with that one. So here the first one we are gonna do here, word counts. All right. So in word count, how we can do that word count? We can get like this df, and on the twits, so it has df twits, and in this df twits what we have, dot apply, and then here we have lambda x. All right, and there we have, you see here, this is lambda function which we are going to use on this tweet. So this lambda function, what it does, it takes the data frame, this data frame row by row. So each row will be passed into this x variable. Now we are going to calculate the total number of words in that x variable. So to do that, we need to get the length of x dot split. So what we are going to do here, str x dot split. I'll tell you why I have done this str, because at some point in any tweet there could be a numeric character, and numeric character cannot be splitted. So that is why I'm first converting the characters into the string and then applying here split. Once it is splitted, then it will produce a list of words, and in that list of words I'm calculating the length of that words. And now you can see here the length of that word will be calculated. All right, so each of these words, now we are going to save this into new column, and that column name I'm gonna put here word count. Okay, so this is the word counts. Now let's go ahead and get the head of this df. Now you see here the word counts here has been 19 in first tweet and 21 in second tweet, 18 in third, and 10 and 21 and so on, for all the values for all the rows. Okay, so this is the word count. Next we are going to do a character count. All right, so in the next we are going to do character counts. Okay, so in this character count, what we are going to do, similarly as we did for word count, we are going to do same here. Car counts in character counts is equal to the same formula we are going to use here, df dot twits, and then I'm gonna do here apply dot lambda x. That means the value of each row will be passed into x variable, and then I'm going to get the length of that variable. All right, so here that's the x, length of x. Now with this I can get the length of each character, each rows. Okay, and then here we have df dot head. Now let's go ahead and see. Now here character counts is 115, 111 and 89 and so on. So this is the character count. So we have extracted two features, word counts and character counts. Let's go ahead calculate average characters in each word. That's mean average length of each word, which we can say like average word length. Okay, so in this average word length, how I'm going to do here, I'm going to do as we did earlier, but here I'm going to say that the df average word length. Okay, so here avg and the word underscore length is equal to df, and then we are going to pass here the tweets. Okay, the tweet row, tweet column, and there once again I'm gonna apply here a lambda function as always, lambda x, but here I am going to first write a method which can count average word length. Average word length means how many characters in each word on average. So that we can do like here, def get avg word length. Okay, so here it is average word length. There I am passing here x. And one thing you need to see here, now we need to pass this get average word here. Okay, it is actually I have not run, that is why it is getting here. So x, so this x will be passed here. Now we are going to first take how many words are there. So to the total word length actually, so that's the words, how many words are there, so that's the x dot split. So this is the total words here, and then I'm gonna calculate here a word length. Okay, so what is the length of words? That is actually the total word length. So we are going to do this like the word length is equal to the 0, and then for word in words, and after that I'm going to put here word length is equal to, I'll tell you how I'm going to do this, word length plus length of word. Okay, all right. So this is saying that this is essentially same. Here what I'm going to do here, I'm calculating the word one by the length of each words one by one. But essentially this is the total character length divided by the character length in each words. Okay, so I'm gonna return here, what I'm going to return here, word length then divided by length of words. Okay, essentially this can be also write as length of x and then divided by length of words. So these are the same actually. Okay, perfect. So it will return this word length divided by total length of words. That's mean how many words are present in each row, and then total character length. Okay, so let's run this and run this. So if you are not able to understand, you can understand like this. Let's say this is NLP lesson. So in this you see how many words are there, 1, 2, 3 and the 4. So they have 4 words, and what is the character of this string? Sorry, what is the total length of this string? So it's 18. Now you see here 1, 2, 3 and the 4. So they have 4 words, and then we can say divided by 4. That's mean 4.5 character per word. Okay, so this is how it is working. Now let's go ahead and see this into df.head. In this now we have got 3 features: word count, character counts and average word length. All right, so this is essentially same. Even without calculating that, you can also find out like this. This is essentially the 115 divided by 19. If you see here 115 divided by 19, this should actually come here. Okay, so what is happening here, this total character length is actually is keeping special characters while calculating the word counts. All right, so that is why it is varying a little. Otherwise where it is exactly the same, so there the word length, I mean the average characters per word will be the same. And this is not working, because if we count total characters, then the spaces also, white spaces get into the count. But if we do the word by word count, then the spaces does not account into the the total the character length. That is why it is happening. Because if we calculate here, this is an NLP lesson. In this you see here 1, 2 and the 3. So there is 3 space. All right, 3 white space. But actually this is not the characters in word, and the word character will be length of these characters, this character, this character, and this character, and then it will be the summation. So essentially this will be a little wrong. So what I can say that this is not equal to this one. Okay, so this is not equal to this one. All right, so we have to first split this word by word and then count the length of each word, and then finally the total number of words divided by total word length. So this is how it is being calculated here. All right, so let's go ahead and get the count stop words. How many stop words are there? If you remember here, I have imported the stop words from the spaCy.language.en.stop words. Here, this is the total stop words. All right, so let's go ahead and do this stop words count. Okay, so stop words count here. Let's go ahead and first print this stop words. What are the stop words? Stop words are those words which occurs very frequently in text data. So those are the stop words, and these very frequently occurring the words doesn't have much information in the text data. But always do remember that in some cases these stop words could be very important. Like if you are trying to find the context meaning of the sentence and syntactic meaning of the sentence and semantic meaning, etc., and you are trying to understand what this sentence is saying and about what and who is saying. So all these information is only can be found if there is stop words. So removal of stop words are not always recommended. You have to see that where you can remove these stop words. But as of now, I'm just going to show you how you can remove the stop words if it is necessary for your text processing. All right, so here I'm going to do here TF tweet, as we have been doing TF tweets dot apply, and then we are going to put here a lambda function, and in that lambda function what I'm going to do here, I'm going to calculate the length of stop words. Okay, so this is very important here. You need to understand how I am doing. So what we are going to do, we are going to split this X into the word, and then we are going to see word by word if that is present into the stop word. So I'm going to first here apply a for loop for t in X dot split. All right, so in this t is a particular value if we split this X. Okay, and now we are going to see here if this t in stop words. Okay, if this t in stop words, then put that t into a list. All right, so here I am going to use this as list. So this is very important. You need to understand this. For your understanding, what I can do here, I can put here text data. Let's say this is text data. All right, and I am going to copy it here for your understanding. Now you see here this X will be splitted here, and then it will be read one by one, and then finally it will be compared, and then it will be printed. See here. Okay, now you see this is to understand it in a better way. What I can do here, I can show you it one by one. Now you see here, if I say this X dot split, this, now you see X has been splitted into multiple words. Now this is a list of these words. Now a for loop on this list is going to take a word one by one into a t variable, and this t variable we are comparing, we are seeing if that t variable is into the stop words, put that t variable here. All right, and if we print this, we will get here, so the total words which is available into the stop words. So here this and the age is available into the stop words, and putting a length, that's mean the length on this will give you how many stop words are present in this text data. So for this example it is 2, and the similar thing I am doing here. So since I am using here a lambda function, I'm once again telling you that lambda function is really very important, and you need to understand how this lambda function is working. Throughout this video series, I'll be using this lambda function very often. Okay, so now it will return a length of stop words present in a row, and that I am going to store into a new column, and that column I am saying that stop words underscore length. So that is the stop words length. All right, now let's go ahead and see the head of this data frame. It might take a little time because it is comparing each words one by word, looking into the stop words. Now you see here we have got the stop words length as well. So there are 4 stop words present into the first tweet and 9 into the second tweet. All right, now apart from that, let's go ahead and see how many hashtag and mentions are present into the tweet. So you see here, if any word starts with @, that's mean it is a mention, and if a word starts with hash, that is hashtag in a Twitter. So let's go ahead and here count hashtag Okay, so what I'm going to do, I'm going to again use a lambda function here. As I did it here in a stop words, same things I am going to do here. So let's go ahead. For example, I'm going to show you how it will work. Let's say this is hashtag and this is mention. So let's say you have X here. Now what I'm going to do here, I am going to split this X in X dot split. All right, sorry, I don't need this X here. Now you see this X has been converted into a word, okay, and word tokens. In these word tokens, I'm again going to apply a same for loop in a list as I did earlier. So here for t in X dot split, okay, so this is how it is working. And since X dot split has been already done, so here I'm going to do the X dot split, but let's go ahead so that I can make it okay. So t in X dot split, now you see in X dot split it is a list which have words. Now t in X dot split, and what I'm going to see here, if this t starts with, okay, if t starts with hash, all right, then print this t here and make it a list. Okay, now you see there is just a hashtag. And similarly, if it starts with @, then there is a mention. So this is how we are going to do this. All right. Now to do this for counting purpose, so tf dot hashtags count is equal to df dot twits. Then here we have dot apply, and this dot apply, once again we are gonna here lambda function, we are gonna use lambda function lambda x, then again length of that length of this. So I am going to just copy that and I'm going to paste that here. And since this is for has function, so this is has, and once again I'm just going to copy this and paste it here, and I'm going to make it for mention. Okay, so here we have mentions count. Okay, so it might take a little time. Now it is going to say, now it is going to store the total count of hashtags and the mentions, and once it is done, then we can do the df.head and we can see it. Now in df.head you see the mention counts and the hashtag. In the first one there is mention, but in the second one there is no hashtag and mention. All right, so this is how we can calculate these features. Now the next step, I am going to count if I'm going to see if there is any numerical data present in a tweet. Okay, perfect. So that I can say that if numeric digits are present in tweets. So similarly, as we applied our lambda function for other features, we are going to do same here. A numerics underscore count is equal to df. Then I'm going to apply here tweets, df tweets, then dot apply, and there I am having lambda x, and there I am having here length of those numerical counts. So the same I'm going to do here, the t for t in x dot split. Okay, and if t is digit actually, okay, if t is digit. All right, so with this I'm going to get if there is any numeric data is available. Okay, now apart from this, what I'm going to do, let's go ahead and visualize this. Now you see here there is no numeric data in first 5 tweets. All right, so this is for numeric data. Now I'm going to calculate if there is any uppercase present in a tweet. Okay, so uppercase words count. The uppercase word count is very important because often people mention happiness and rage in uppercase. When you might remember that whenever you have tweeted ultimate happiness or rage about someone services or about someone, then you might have put some words into uppercase to emphasize those words. So uppercase word counts are very essential while calculating the sentiments. So here the df uppercase are upper counts. Okay, once again we are going to use here a lambda function. Okay, I'm again reminding you that lambda function is very important. While working as a data scientist, you will be always needing this lambda function. So the lambda x, then I'm going to calculate this uppercase. Okay, as I did earlier, I'm going to create here a list for t in x dot split, and if this t is upper. Okay, is upper. The one thing I should tell you that if I say that t dot is upper, then if there is somewhere I or some one word or the two word, then mostly people write in the upper the word upper sentences. So that actually doesn't reflect that emphasis on the word. So what I'm going to put here, I'm going to also put that and length of that x is greater than 3. That's mean word length should be the greater than 3, and that is, if that is in uppercase, then it is going to set a flag of that, I mean how many upper letters are there, into the upper counts. All right, so let's go ahead and see this in a df.head. So this is how we can see that with the df.head. All right, perfect. Okay, so let's go ahead and see some tweet like log 96, and then here I'm gonna say that twits, and in this now you see here these are the mentioned into the upper words. Okay, so it says that okay, the person is trying to put the emphasis on the sentence, these words, like sadly since it's Easter I won't be able to do much but oh well, etc. All right, perfect. So this is how we have calculated these features manually. Now let's go ahead and do some pre-processing and cleaning in this text data. All right. In pre-processing and the cleaning, what we will be doing, we will be converting the upper cases into the lower cases. We will be removing the hashtags and the mentions and the special characters, etc. So let's go ahead and start this pre-processing and cleaning. All right, so the first step which we will be applying on pre-processing and the cleaning steps, that is a lowercase conversion. Okay, so in this lowercase conversion, what I'm going to do, I'm going to do the df twits, and then again the df twits dot apply, and then again lambda function x and x dot lower. Okay, so in this way it will be converted into a lower case. Now you see here a df is converted into a lower case, just 2 lines. Okay, all right, so another step which I'm gonna do here is correcting contraction. Okay, contraction to expansion. I'll tell you what is this contraction to expansion. Let's say you have something x is equal to this should be actually in double quote. I write it in small. I don't know what you want. Okay, so now you see here this is a contraction, and this should be converted into I do not know. All right, so there could be a lot of other contractions which we might need, like can't. Okay, like he will, something like this. Yeah, he shall, or something like this. Okay, otherwise you might get something like this, I would. Okay, so these are the contraction which should be expanded before we do a further processing. These are really very important to understand the meaning or context of that sentence. So these are the contraction. I have a list of contraction. I have got this list from the Wikipedia, and I just would like to share you that list here directly. I'll show you this list, this contraction list. In this contraction list, and will be converted into the am not, and then can't will be converted into the cannot, and aren't will be converted into the are not, and cannot have, and this cause will be converted into the because, and this will be converted into the could have, and so on. And then last you will see here, u will be converted into the u, your will be converted into the your, and n will be converted into the and. Okay, so the n is standalone L. You see here there is a space, extra space here and there. There is a space and here. Like people write that I and you. Okay, so like if someone writes like this I and you, that means essentially this means I and you. All right, perfect. So this is how we are going to do this contraction to the expansion. So let's go ahead and write this the method. So the def cont contraction to expansion, okay, x. And in this what I'm going to do here, if this type of x is str, that's mean if it is string, okay, then I'm going to get these key values and look into the word by word and see if this can be converted into the expansion. Okay, so for key in contractions, and then we have value is equal to contractions and with that particular key, value of that particular key, and then I'm gonna say here x is equal to x dot replace and that key with value. That's mean if there is something to have has been found in the text, then it will be replaced with this value, that is the to have. Okay, and then here I'm returning that x. If that is not a string, that's mean if it is a numeric number, then it will be returned as it is, that is the x. Okay, perfect. Now if you see here, let's go ahead and create x like this. Hi, I would be happy. All right, so let's go ahead and get this contraction to the expansion and pass this x. Now you will see here, this says that hi, I would be happy. That means it is not converted. All right, so there is a reason why it is not they got converted, because we need to see it. We need to see it the one by one. I don't think I would is there, so let's convert this. I think there should be I would. Okay, so this is in actually the capital. What we need to do, we need to also convert that into the small words as well. All right, perfect. Let's say if I say it like this, it will be converted into I would be happy. All right, so here we have a contraction. Then if I directly say it as lower, then of course dictionary cannot have that lower part. What I need to do, let me correct this. Okay, it won't take much time, just wait a second. Let me correct this, especially this I part. So there I should correct this. Oh sorry, this I, and here it has this I, and this I should be in a small one, and this I should be small. I is small, this is small, this is small. Okay, perhaps everything is great. Now let's go ahead and see it if I put it into small. All right, so hi, I would be happy. So it is now working. Let's go ahead and apply a lambda function on twit. So I'm gonna put here a time so that I can get how much time it is gonna take here. So it's the twits is equal to df dot twits dot apply. Then here we have lambda function of x, All right, and then here contraction to expansion. Just wait a second, cont to expansion. Okay, in this I'm gonna pass here x. So it might take a little time. Let's go ahead and wait for that time to complete this. All right, so it took around a minute to complete this operation. Now we have done a contraction to the expansion. Now this is time to see a df if there is in any tweet we can see. I don't think we can see. I mean, we had not found that. Although, let's go ahead and move to the next topic, in which I'm going to remove emails. Okay, so I can say that count and remove emails. So I'm going to see that if there is email present in these tweets, so I'm going to extract those emails, and then I'm going to count the number of emails which is present in any Twitter, and then finally I'm going to remove those emails. All right, to work with this one, we need to import here RE, which is a regression, okay, which is a regex actually. Now what I'm going to do, let's take an example here. Okay, so in this example I'm saying that, hi, email me at email@email.com. all right, so this is x which we have. Now we need to extract the emails present in this the text data. So I'm going to use re here. I have a function, so I'm going to directly apply that function, and then I'll explain you. See here, it is saying that get all the data, which includes lower or upper cases, including the numbers, plus signs, dot, and underscore, and the hyphen. And apart from that, then there is the @ and then there is the another data which can include the numbers, upper and the lower cases, has underscore, dot, and hyphen, and then finally in last as well. So it is kind of like this. Okay, and I'm gonna get that email. Now you see here the email @email.com, and let's go ahead and put the another email here. We have here another @email.com. So let's go ahead and get that as well. So we have got the both of the emails from this data here, and then we can calculate the length of this one to get the total number of emails as well as the emails. And then finally we will remove this. So let's go ahead and apply this into our pandas data frame using a lambda function. So the first of all, I'm gonna get the emails. So here df emails is equal to the df, and then there is tweets dot apply. In there I'm gonna use a lambda function as always, and in that lambda functions, as I told you, that we need to just copy this and paste it here. All right, perfect. So let's go ahead and run this. It will find all the emails present into the data set. All right, perfect. So it has got the emails. Now let's go ahead and get the count of those emails. So with that we can get like df emails underscore count is equal to df, and then I'm going to apply that into the emails. Okay, dot apply, and then there is lambda of x, then return the length of that list if there is any emails. Now let's go ahead and see how many emails are there. We can get that df and get where email counts are greater than 0. All right, perfect. Let's go ahead and see it. So there is the list of 564 rows where emails are present into the data. All right, so these are the email which are present here. Mostly are the Gmail, LinkedIn here, and the other emails we also have here. Some people are some peoples are there, posting the emails, and then you can extract those emails. Now we have got the emails and the email count. Now our task is to remove these the emails from the actual Twitter data. All right, so let's go ahead and remove these emails, which we can do like df and then twits is equal to df and then again here a twits. The one thing I should show you that how we can remove the email. Let's say we already have our X here, okay, which earlier we had. Now we want to remove these emails from this text data. Now how we can remove? So we are again going to use here regex function. So I already had that one, and the same way what earlier we had done re.findAll, but at the place of findAll I'm just going to put the sub, okay, and after that I am going to say that substitute if anything, which is something like that with nothing, and that is going to take the value from the X. So let's go ahead and run this. Now it says that hi my email, hi email me at and something. All right, so this is how we can do this. So let's go ahead and copy this. In the tweets we are going to apply here a lambda function in the X, and let's go ahead and paste it. Okay, perfect. So now you see it will remove all the emails, okay, from this text data. And again we can see here this one to understand if those emails are removed actually or not. Now if we run this, now you see the emails are removed from the Twitter data, but earlier you see here the emails were there like who stole or something like this, but now it is just who stole, okay, but the counts and the emails are already stored into the another columns, emails and the emails count. All right, so this is how you can calculate the emails and how you can remove the emails from a Twitter data. Now similarly I am going to use it for URLs, okay, count URLs and remove it, okay, as we did for the emails. In the same way we are going to do this, okay. So let's go ahead and test it. Hi, to watch more, visit like this https://youtube.com/KGP Talkie. All right, so here we have X. Now our task is to first extract this link and then count total number of link and then remove this link from the data. So we are going to do this again as we did for the emails, and once again we are going to use here, okay, regex. So you see here this is very complex, so I have taken this from the regex website, and it says that if it starts with the HTTP, FTP or STTP or something like that, then we need to get the word and etc, all those things, and then just remove this. All right, so let's go ahead and run this. Now you see here it has found that all the HTTPS, youtube.com and the KGP Talkie, etc. All right, so this is actually the link which is the present here. All right, perfect. Now let's go ahead and find out how many the URLs are there. Okay, perfect. So here we have URLs underscore count is equal to I'm gonna say that here the URLs, okay, I'm gonna say that here URL flag, if there is a URL, okay, is equal to df, and then there is twits, okay, then dot apply. There I'm gonna say that a lambda function x, and then again I am going to apply this lambda function here. All right, so let's go ahead and apply this lambda function here. Okay, now it says that len so length of this one, okay, perfect. All right, so let's go ahead and get this. Finally, we are going to remove the links, and to remove these links, what we need to do here, as we did earlier here, we can just copy this and paste it here, and then we can say that replace it with nothing, and then just run it. Sorry. Sorry, let me see it. Let me get it from here. Okay, I think I had forgotten that sub. Okay, so now you see it has removed those link. All right, perfect. So let's go ahead and apply this into our data frame. Here we have df.twits is equal to df.twits dot apply. Then again here we have lambda function x, and then just we can copy it and paste it here. Let's go ahead and run this. It will remove all the links, and then finally let's go ahead and see this df.head. Okay, since we wanted to convert this into the flag, we have not done that actually. You see here in URL flag, perhaps okay, so here you see the df.log at the first place, that's the 0. Then we are gonna see here twits, and this says that that is the removed, yeah, website is removed from here. Okay, perfect. So this is how URL we have removed, and we have also got the flag for that URL. Now what we are going to do here, we are going to RT. Okay, so the RT is stands for the retweet. If someone is retweeting something, so the RT gets included into the tweet. So we are going to remove this RT. Okay, perfect. To remove that RT, it's really very simple. What we can do like this: df twits is equal to df, then twits dot apply, and then there is lambda function x, re dot sub, and then here we have rt. All right, replace it with nothing and it from x. So with this, now you will get the tweet without any RT in that. Now in the next step, I am going to remove any special characters, which you can say or punctuation removal. Okay, so the special characters and the punctuation removal. Now what we are going to do here, we are just going to keep alphanumeric characters and that's it. Okay, so the df, and then here we have twits is equal to df, and then here we again have twits, then dot apply, and there we have lambda function of x re dot sub. Okay, that's mean we are going to subtract here with the raw. We are going to subtract it. I am going to get that complete the expression or a pattern. So this is the pattern which we are going to keep, and others will be subtracted actually. Okay, so we are not putting here r, so r remove, but this is going to get this one. Okay, so it is just going to get the alphanumeric characters with the hyphens. All right, and all other punctuations will be removed from here. It says that something like this perhaps. Okay, now with this you will get here. Okay, now you see all the extra alphanumeric characters are removed. All right, perfect. Okay, so this is how we remove the special characters. Now let's go ahead and see how we can remove the multiple spaces. Multiple spaces like something this. Okay, so here you see there are multiple spaces. If I write something, let's say hi, hello, so there are spaces present into these strings, so we need to remove these spaces. All right, so I can say that like this. Thanks for watching, and please like this video. Okay, so dot join and then x dot split, and let's go ahead and put some extra spaces or random spaces. All right, now you see those random and extra spaces is removed once we perform this action. So here we are gonna say that df then twits is equal to df, and then here there is twits dot apply this lambda function x, and in that what I'm going to do here, I am going to remove those extra spaces by just calling this one. Okay, perfect. So with this, those extra spaces will be removed. Let's go ahead and see first two lines. Although we did not have any extra spaces, so we can't see that here. Anyway, so those extra spaces are removed. Now let's go ahead and see how we can remove HTML tags. Okay, so to remove these HTML tags, what I'm going to do here, from bs4 import beautiful soup. All right, then let's say if we have some x something like in HTML, like this. HTML, thanks for watching. Now our task is to remove these HTML tags and get these texts only. So what we can do, we can get those from Beautiful Soup, that X, then LXML, and then this is get text. Beautiful Soup is a library which used for scraping a website, and if you do not have a Beautiful Soup in your computer, then you can download it from the internet, and then you can install. Search on internet how to install Beautiful Soup, and then you will get the instruction how you can install Beautiful Soup in your computer. Let's go ahead and run this. Once we run this, we should get I think this is wrong. Beautiful Soup, beautiful, I think here it is wrong here. Beautiful Soup. Okay, perfect. Beautiful Soup. All right, so here, thanks for watching. All the extra tags, HTML extra tags are removed. Perfect. Let's go ahead. Let's go ahead and run this for the twit. So here we have twits is equal to df, then twits dot apply, and there is lambda function x, and there again we need to do here Beautiful Soup, that Beautiful Soup x, and then LXML, and then finally get the text value. Okay, get text. So this will remove if there is any HTML tags present into the Twitter data, although this is very less expected that if there is any Twitter data. All right, so in meantime it is processing. Let's go ahead and move to the next part. In the next part, I'm gonna remove the accented character. Okay, remove accented characters. Accented characters are something like, let's say if I say if something X is like this, okay, so this is the accented character. Now we need to write a function so that we can remove this accented text from the data. All right, so we are going to just write a function here. The function is remove accented characters, and it is very standard format actually. There you have Unicode data dot normalize nf kdx encode ASCII and ignore if and decode the UTF-8 ignore. All right, so it will convert this accented text into the normal text. All right, so let's go ahead and see this. In meantime, it is taking some time. Let's go ahead and wait for some time. Okay, so now as you see here, the processing time has been completed, and it took around 11 minutes to complete this one, where we were removing HTML tags. And we have in meantime also written another function, remove accented characters. And if you have something like this accented characters, then I have written this function to remove these characters. So let's go ahead and run this, like remove accented car, where I'm going to pass here X. This says that, let me see what it says. Name Unicode data is not defined. That's mean we need to import that as well. So import Unicode data, import this one, then this one, run this one, and finally this one. Now it says that okay, this accented characters has been converted into UTF-8 or ASCII characters like accented text. All right, so this is how you can remove the accented characters. And as we did earlier here, to apply this on all the Twitter's data, you can do the same thing. Since it is taking now a lot of the time, so I'm not gonna do this here. And but you should do this if you are doing your the text processing. Actually, it depends what type of the data you have. Accordingly, you can do. Since this is the lesson where we will be doing a lot of the text processing, different kind of the text processing on the data. So it is good to learn all the aspects of the text processing, whether you apply it or not in your current project. But it's good to know all these text processing techniques. All right, now we are going to do a few more text processing techniques, but now on we will be using Spacy to do this. Earlier, if you remember that I had imported the Spacy here, Spacy and NLP together. I'm gonna do this. So I already have imported the Spacy, but once again I'm just going to import the Spacy for the simplicity. And we already have the stop words. Okay, so the first of all, I am going to remove here. You know what I'm going to remove here? I'm going to remove the stop words. Earlier, if you remember, we have calculated the stop words count, but now we are going to remove these stop words. Okay, all right, so let's go ahead and apply that into the twits data. So here we have this twits data is equal to df, and then here we have twits dot apply, and then we have lambda of x. All right, now we need to remove stop words. That's mean we need to find out if that character is not present into the stop words. To do that, you can understand that like this. Let's say you have x is equal to like this. This is stop word, words removable code. All right, so here what I'm going to do here, I'm going to use here join, and then I'm going to create here a list, and that list is like this: t for t in x dot split. Okay, x dot split, and then I'm going to check that if t not in stop words. Do you remember the stop words? Then in this way it says that stop words removable code. That's mean it is discarded. This is because this is a stop word. Okay, like each, a, the, and, how, what, all these are stop words, so this will be not included in the final text. All right, so this is what I'm gonna do this. Let's go ahead, copy it and paste it here. In the same way, run this. Now it will remove all the stop words from the Twitter data, and now it will give you the tweet data without any stop words. All right, now you see there is no stop words. Perfect. Now we have now removed the stop words. Let's go ahead and convert it into a base form. Okay, convert into base or root form of word. All right, so I'm gonna convert this into a base form of a word, and to do that we need an NLP library there. So NLP dot equal to the Spacy dot load, and there I'm gonna load here a Spacy library data, which is en core underscore wave and then underscore sm, which is a small size. If you do not have this Spacy, then you need to download it, as I told you at the starting of this lesson. And if you do not have any experience in SPACY, then you can go to my channel KGP Talkie, and there is a playlist natural language processing tutorial, and you can watch SPACY tutorials from there. Alright, so with this I'm going to load NLP library, okay, with a small size. Now let's go ahead, take an example like x is equal to like this. Let's say I take this one, okay, as x. Now we have x. Now you see here in x, this dived should be converted into a div, because that is the base form for that one, and time is base form for times, and manage is base form of managed. So overall what I want to tell you here is that I'm going to convert it into the base form. Why base form is required? Because if it is not converted into the base form, then the vocabulary library or vocabulary will be very large, because this div and dived will be treated as two different words, and at the same time this time and the times will be treated two different words, but the essential meaning of these words are the same. Now one thing also, you also need to remember that the techniques of converting into V's or root form depends on application to the application. Because if you are detecting the meaning of a text, then definitely you should not convert into the base form, because the different form of verb shows that the different the work done into the different time frame, like past, present, or in the future. So it depends on at what project you are working, and whether you need to convert it into the base form or not. Alright, so let's go ahead and write that function def make to base. Alright, then here I'm gonna say that x underscore list is equal to an empty list, and then doc is equal to NLP of x, and then for token in doc. Then I'm gonna check here a lemma is equal to str, okay, of that token dot lemma. All right, the few things you should also notice here is that I think before doing that I should show you how it can be the different. How should I show you that? Let's say if I have x is equal to I, you, he, she, they, h, m, r. All right, let's say we have x like this, and what happens if we don't do this? Okay, let's go ahead and print this lemma. Call this make to base on the x. Now you see here I is okay, but you, he, she, they are converted into this pronoun, and these verbs are converted into the be form. Okay, but this we do not want. So what we want here, if lemma is equal to pronoun, if lemma is pronoun, or if lemma is be, then we should put lemma is equal to token dot text. All right, perfect. And then we should add this into x list dot append, and there is lemma. And then finally what we should do, we should join it dot join, and then x underscore list. All right, let's go ahead and run this. It says that invalid syntax. we have to see that. I think here this is invalid. Now this is okay, and I should do this print here. Now you see I, you, he, she, they, am, are. All right, so this is perfect. Now in the same time, let's go ahead and pass this x. So let's go ahead, comment this and pass this one. In that way, now if you see here, it has converted that dived into dive, times into time, and managed into a manage. So this is how it converts, it will make a base form of a word. And you can apply this using a lambda function into your Twitter data if you want. I'm not going to apply because it will take very much time. It might take hours or days as well in this huge data set. All right, perfect. So the next step which I'm going to do here, a common word removal. Okay, a common words removal. Why we need to remove common words? Because if any type of words are occurring very frequently, that's when their meaning is not much more specific for that particular of document. It's like a stop words. We have already removed the stop words, but there are another certain kind of word which occurs very frequently in the documents. So those kind of the words might not have a much meaning in a text classification. So we should also remove those words. But always do remember that it might vary project to project, but I'm gonna show you this technique so that if it is needed in your project, you can also apply this technique in your project. All right, perfect. So let's go ahead and first join all the text. So how we are going to do here, let's say we have here the tweet data, and so this is the tweet data. Now what we want to add all these words together. Okay, so that we can do with the join. Okay, here we have dot join. All right, so with this we will convert all this data into this single sentence. Perfect. Since we have just taken initial 3-5 rows, what we need to do for all the rows. Okay, so here I'm saying here confreg. Okay, instead of confreg, let's do like a text. So the text is equal to what I'm going to do here. The text is equal to like this. So let's go ahead and take this and paste it here, but remove this head so that we can do this for whole data. Okay, so with this we have got all the text together. These texts are combined together. Now let's go ahead and split this text and then put it into a pandas series. Okay, so we can do like this. Text is equal to text dot split, and then finally that's mean frequently occurring or common word is equal to pd dot series, and in this series I'm going to pass this list which is a text, and then I'm also going to count the value for each of the words. So value counts. All right, let's go ahead and store that into this freq_com. Okay, let's go ahead and print this frequently occurring words. It says that good, day, like, and this hyphen and the today has been most occurring words, while these are some other kind of the words which have occurred least time. Okay, so rarely occurred in whole data set. So this word occurs only one time in whole data set, and these other words also has occurred only one time in this data set. So what I'm going to do, I am going to remove I'm going to just take first 20 occurring words. Okay, so these are the top 20 occurring words. Now you see here Okay, so these are the top 20 occurring words which we want to remove. All right, so we can write it like F20 is equal to like this, and now you see here F20 is here. Okay, so as we did like as top words, similarly we are going to do here F twits is equal to DF and then twits. If you remember, I have been telling you that you need to always we need to always apply here a lambda function. I mean mostly, so it's always better to learn lambda function. So the lambda x here, and again here like a stop words we did join, and there is list like t for t in x dot split, and then we need to see that if that t is not in that F20, that's when if that t is not present in F20, then add that into the database, that's when add into the Twitter word, otherwise that will be removed. That means we want to remove these most frequently occurring words. Okay, perfect. So with this we have removed it. It says that invalid. Let's see where it is not valid. I have to see this. df twits is equal to like this, apply lambda x join, and it's okay here, the t for t. Okay, here I need to apply if t not in F20. All right, so this is how we can remove the most occurring type of the words, most top 20 occurring words. Okay, perfect. In the same way we can remove the rare occurring words. Okay, although this is happening here, but in meantime we can start writing here. Okay, rare words removal. Sorry, this should be actually rare words removal. All right, so the word frequency we already have here. Okay, so in freq.com, now if we print that freq.com here, you see here at the upside we have most frequently occurring words, and in last we have rarely occurring words. So what we are gonna do here, we are gonna take rare 20 occurring words, and that we can get from this. We can select actually this should be minus 20. Okay, like this, and then here we have these. Okay, the rare occurring words. So this is how it has the least frequency, the rare occurring words. Otherwise we can also get the words which have at least one frequency. Okay, I mean at most one frequency at one time. Okay, the words which has occurred, we can also get those the words from com freq, impact from freq.com, and in the freq.com we have the index values. Okay, which values are 1. So this says that the total number of word which has occurred just single time. So this word length is very high, and these are the word which has occurred only at least single time. Okay, at most one time. But if we process this all these words, it is going to take a lot of the time. So I am going to just take these rarely occurring these 20 words and to show you the methods how you can do this. Although you can use all these words together if it is intended to use in your project. Okay, in the same way here we have df twits is equal to df twits. Sorry, here we have df twits dot apply, and then again we have here a lambda, sorry, dot apply, oops, sorry, dot apply, and then here we have a lambda of x. All right, perfect. Now we are going to see that in the same way if that word is not present into the rear 20 as we did earlier. So here dot join, and I'm gonna do this with list t for t in x dot split, and if that t not in those rear 20 words. All right, so this is going to process, but it says that here I think we are missing dot. Okay, so we have removed most occurring words and least occurring or rarely occurring words, and we can also see the first 5 lines of a data frame. All right, so these techniques are really going to help you a lot in your text processing or NLP project. Although there are a few techniques which you might not be, which is not, you might not use few techniques in your NLP projects, but most of the techniques you can use in your NLP projects. Overall, it depends what kind of projects you are doing, and then related text processing techniques you can use, which I am telling you here. Okay, so we have removed most frequency and rarely occurring words. Now let's go ahead and see the word cloud. Okay, so here we have word cloud visualization. Okay, the word cloud visualization, which is kind of visualization in which we will be seeing the words in the form of images. And if you do not have a library which is needed for this word cloud, you can install that pip install and then with word cloud. I have already installed this library, so it will show that the requirement is already satisfied. All right, but if you do not have word cloud library, then you can install this. Now let's go ahead and import from the word cloud, import this word cloud. Okay, and at the same time we need to also import matplotlib dot pyplot as plt. Okay, and then here we have matplotlib inline. So it is required to include the matplotlib because the word cloud uses the matplotlib internally in the backend, and it is necessary for this project. Perfect. So we are going to get the text data, which we already have the text data. So what I'm going to do here, I am going to take the text data, let's say into form in the X, but not all the text data. I'm just going to take just 20,000. Okay, because I took the 20,000 because this text size of this text is huge, and if we plot this with the word cloud, your computer might get hanged. So I'm just going to take just few words to show you that how you can do this. Okay, all right, perfect. And in the next step, which I'm gonna do here, I'm gonna create a word cloud object here, so which we can get here the word cloud. Okay, word cloud is equal to, here we have instead of word cloud, let's call it WC, and then here we have word cloud. And in the word cloud, if you press shift and the double tab, you will see that what are the parameters which you can pass as an input in the word cloud. So I'm gonna pass here width and the height only, and others I'm not going to pass parameters, but you can play with this one. Okay, perfect. Let's go ahead and pass the width. So the width I'm gonna pass it as 100, and height I'm gonna pass it 400, and then I'm going to call here generate and then finally this the word which is in X. Okay, perfect. Once it is done, then I'm gonna call here the plt dot imshow, which is image show, and directly is wc, that's mean wc image, show it here, and then plt dot axis, I'm gonna call it as off so that the axis should not be shown there, and then finally plt dot show. All right, let's run this. It says that there is error expecting string or byte like object, but I think it has got something else here. I think in the X it has got the error in X. Let's see what is the X. Okay, X is actually it is saying that this is the list, so we have not got the X correctly. But what I can do here, I can join it here to get the right X here in the form of text. Let's go ahead and call it as join. All right, now let's go ahead and run this. Now if you see here X is in the form of text data. Okay, and this is the text data which we want. All right, now you see here we have got our word cloud. And in this you see their work day and God today. This is really looking very cool. You might have seen this on the internet. You see here how simple it is. You can plot this word cloud. All right, now moving to the next step. In the next step, I'm gonna show you how you can do a spelling correction. Okay, for a spelling correction, there is a new library which I'm going to introduce in this lesson. That library is text blob. If you do not have this text blob, you can install this text blob. And apart from this, there is the text blob corpus you also need to install. So these two you need to install. I have already installed these. It will take some time, so I'm not going to run this. I'm just going to comment this. But if you do not have text blob installed in your computer, you need to install these two libraries in your computer. So now we are going to use text blob the spelling correction. So from text blob, okay, import text blob. All right, the one thing we should notice here is that let's go ahead and take some text like here. Thanks for watching this video. Okay, all right, now you see here only this is correct, but none of other the words are correct. This is wrong words. Now we are going to pass this into the text blob and see how it is going to correct this. But the one thing always you should remember that the text blob spelling correction corrector is not so much accurate. In the term of the technicality, it is accurate, but the corrected word which is supposed to be in your case might be the different, and text blob might suggest you the different. Because let's say if I say here, okay, CARR. Okay, now we have X. Let's go ahead and correct this spelling. So what I'm going to do here, I'm going to say X is equal to text blob, and that text blob I'm going to pass here X, and then I'm going to call here correct. Okay, and now we are going to see this X here. This is say that okay, X is like this. Text blob correct. Okay, we have run this. Sorry. Okay, we need to run this and this. Okay, and now as you see here, what we are getting here, The thanks is thanks. I intended to correct it as a thanks, but thanks, since there is a spelling thanks, so it is not corrected. But for is corrected. Watching is also corrected here, you see, and this was already corrected. Video is corrected, and this care, this CARR has been corrected into like this. But this could be the carry as well, like this. Okay. So let's say if I say like this, now you will see here this is corrected in a carry. In correct parameter, you see it doesn't take any parameters. It will try to correct this based on the some internal techniques where it calculates the overall distance between the nearest correct spellings and how many characters it need to delete or insert. Alright, so this is how you can do the spelling correction. Now let's go ahead and see the tokenization. The tokenization we have already seen here, but I'm going to cover it into a separate the section here. A tokenization means converting a text into a tokens, okay, or individual words. But here you see, let's say if I say thanks for watching this video, okay, please like it. Now we have X like this. What we need to do now, we need to tokenize it using text blob. Okay, so with the text blob like this, text blob dot X, then dot words. So with this you will get it like this. Okay, so it is tokenized into thanks for watching this video. But if I say it like this, and the thanks for watching, now you see thanks for watching has been put into a single word. Okay, so this is how we can use using a text blob, but we can also use it using a spaCy as well. So we can do like doc is equal to NLP and X, and then for token in doc, okay, print token. Now you see here it is converted in the same way like this, but earlier you see using a text blob, this dot actually this was removed while tokenizing this, but in spaCy this the dot has been put into the tokens. So it depends which type of library you are using, and according to that it will return you tokenized the tokens. Now if you put here a special characters like this, now you see here with this special characters it has tokenized and removed this hash. But in a spaCy, if you see, it has put that thanks, hash and watching together and like this. So it's completely depends which library you are using, and according to that tokenization will be done. All right. So now I am going to use a lemmatization. Okay, lemmatization I have already shown you using a spaCy during our make to base section, where I had used a lemma which converts any word into its base or a root form. But here lemmatization I am going to use using the text blob. Okay, so let's say you have X like this, but this X is not intended what I'm trying to use it. Like here we have run, and then we have here running, and here we have then ran. All right, sorry, we have runs, running and ran. And let's go ahead and run this and then correct it using other lemmatization techniques. Okay, that is that we can use using a text blob. Okay, so in the text blob what we need to do, first of all, from the text blob we need to import word, and then word. Okay, there we have X, but the one thing you should notice here, this word, lemmatize it one by one. So what we can do here, for the token in x dot split, and then we need to use here a print, okay, where that token, and then finally lemmatize it. Okay, so if you write here, it will lemmatize it. Let's go ahead and run this. Now you see runs, and the run has been converted into the run, but this running and ran is the same. It did not change it. Okay, so this is using a text blob, and the same lemmatization I'm going to show you using a spaCy library like doc is equal to NLP, and there is x, and then for the for token in doc. Okay, so the print token dot lemma underscore. Now you see here, essentially this running and the ran, these are the same, are derived from root word run. So in this case, spaCy library is giving you a better result than a text blob. So it has converted all the form of run into a single or a root form, that is run. Alright, so let's continue to use this spaCy. Now I'm going to use this spaCy in detecting the entities. Okay, so detect entities using NER of spaCy library. So entities means, let's say if a text is given like this, let me get that text directly here. Okay, let's say a text is given like this: breaking news, Donald Trump, the president of the USA, is looking to sign a deal to mine the moon. All right, so let's say this is X, and now we want to get the entities. Entities means it will find out if there is a person name, geographical, political, party's name, all those things, some kind of the entity. All right, if you want to know more about the entities detection, definitely I would suggest you to go at my KGP Talkie channel and see natural language processing tutorial playlist. All right, so here the doc is equal to NLP of this X, and then for ent in doc dot ents. Okay, so we have got the ent. Now I'm gonna use here a print statement. Okay, this print statement, in fact, let me use it like this here. So in this, what I'm doing here, ent.text will get the token, and then ent.label will show you the what type of ent is every word here, if there is ent, and then it will explain that entity. Let's go ahead and run this. It says that Donald Trump is a person, that's mean it is a people, including fictional, written into novels, and USA is GPE, graphical entry, which is a country, city, or a state's name. All right, in another way we can also visualize these entities as well. If we use here displacy from spaCy, import displacy, and then we say that here a displacy dot render, and then we have here a doc, and then we have style is equal to ent. Now in this you see a Donald Trump is a person and USA is a GPE, and this is really very nice visualization. All right, perfect. Okay, so this is how we can do the entity detection from text data, and then we can extract this entity and put it into our the feature vectors. All right, now let's go ahead and detect if there is noun presents in a text. Okay, detecting nouns. And now you see X is like this: breaking news, Donald Trump, etc. In this, let's say if we have any noun, so the for noun in doc dot noun chunks. Okay, the doc we have already got that with NLP of X. Let's go ahead and print that noun and see how many noun is there. So the breaking news, Donald Trump, the president, the USA, a deal, and the moon. So these are the noun present in this the text data. All right, perfect. Now let's go ahead and do the translation and language detection. Okay, translation and language detection. So this is the translation and the language detection which I'm going to do here. So the language code you can get from the let me give you the list of that language. You can get all the language from this link. Okay, let's go ahead and convert this into like this. You can get the language the code from here. Now for a language detection, I'm going to use a text blob. So the TB is equal to text blob and then X. I'm gonna say here TB dot detect language. Okay, so it says that the X is written into English. You see here X was this one. Now what I'm going to do here, I'm going to translate this into the another language, like TB dot translate it into some other language, like 2 is equal to in Chinese language. If we do, so it is converted into the Chinese. And if we do this, like it will convert into a French language. And similarly, if you do it like AR is code for Arabic. Now it is converted into the Arabic language. And similarly, if you do it in HI, then you will get it into Hindi. And all right, in the same way, if you do it BN, it will convert it into the Bengali. All right, perfect. So this is how you can detect a language, and this is how you can do language translation. Okay. Now let's go ahead and use inbuilt sentiment classifier. Inbuilt sentiment classifier. So here I'm going to use inbuilt the sentiment classifier that we get from the text blob. So from text blob dot sentiments, okay, import new Bayes analyzer. All right, so here what I'm going to do here, I'm going to write here new X, that I'm going to say here we all stands together to fight with corona virus. Okay, we will win together. So this is the X which we have here, and now I'm going to detect the sentiment of this X based on this text blob already inbuilt classifier. So the TB is the text blob TB is equal to the text blob, and then here we have X, and then finally we have here the analyzer, and that the analyzer I'm going to use here new Bayes analyzer, and then finally I'm going to calculate the TB dot sentiment. Just wait a second, it will suggest you. Okay, sentiment. Now you see here, you should see here the sentiment of this text. Okay, so this might take a little time because in the runtime it calculates the parameters, and then finally it will show you the sentiment. So it says that its sentiment is the positive, and it is the 82% positive sentence. All right, but if in the same at the same time here, if I say it, copy it and paste it here, okay, we all are suffering from corona. All right, now you see here with this, see how what is the sentiment of this text. This should show you the negative sentiment if it is classifying correctly. Although this is not classifying the pretty much, but it says that 75% the positive, but this should be the negative. So this is how the inbuilt classifier, sentiment classifier, is classifying the text, the text blob inbuilt classifier. So it is always recommended that you should train your own sentiment classifier with a large data set and with a better algorithm to predict right result. All right, now the next step which I'm gonna show you here is advanced text processing. Okay, so here we have advanced text processing. So in this advanced text processing, I am going to use a little bit advanced feature extraction techniques from your text data. All right, so in this advanced text processing, the first subtopic which I'm going to show you is n-gram. Okay, so I'm gonna show you the n-gram. N-gram are the combination of multiple words used together. N-grams with n is equal to 1 is known as unigram, and n is equal to the 2 is known as a bigram and the trigram and the so on. So let's say if you have x is equal to thanks for watching. Okay. Now you see here we have a 3-word thanks for watching, and if I make here text blob tv is equal to text blob of this x, and then finally if we calculate the unigram of from this text like n grams, and then you see here we have the 2. Now with this you see thanks for, okay, and watching, but if you put it in unigram then you will see here the 3 list thanks for watching. But if you make it the bigram, in the bigram you see these 2 words will be taken together, thanks for and then for watching, in these 2 different word list. But if we make it the 3, then there would be only 1, okay, the trigram like thanks for watching. But if you make it 4, then you will not get any list, because there is maximum 3 word present into the list. Okay, I mean 3 words into the the sentence. Perfect. This is how the n-gram works. The next subtopic which I'm gonna tell you, which I'm gonna talk about, is bag of words. Okay, so this topic is bag of words, which is also known as BOW. In the bag of words, how the bag of words work? The bag of word models is the simplest model to extract the features from the text data. It creates a kind of the dictionary, and then it put the count of the words in that dictionary for all the rows. Okay, so to make this bag of word, let's say we have a data like this. This is first sentence, okay, and then I say here this is second, and then if I say here this is last. Okay, Now let's say you have this X, and for the bag of word we need to utilize the sklearn library from sklearn dot feature selection. From feature selection, in fact from feature extraction, and then import the count vectorizer. All right, so here we have count and then the vectorizer. So we get the count vectorizer. It says that it do not have count vectorizer. I think feature extraction dot text, we should get count vectorizer. All right, so let's go ahead and create the count vectorizer instance. CV is equal to count vectorizer, and in this count vectorizer I'm gonna put the n-gram range is 1, and then finally I'm gonna say here the text counts actually. Okay, the text counts is cv dot fit underscore transform, and I'm gonna pass here the x data here in input. Now if you see here text count, what you will see here, this is a sparse matrix. How it is happening? Let's say this is text data, a sentence, and then count vectorizer is counting each of, first of all it is getting the unique words from this whole list, and then it is counting how many times that unique word has occurred in this particular list. All right, so if you see here like 2 array, then you will also get the array of this. Okay, sorry, so this is the array, 2 array, and we can make it like a pandas data frame. So let's go ahead and make it like pandas data frame. So for this I'm gonna say it BOW bag of word is equal to PD dot data frame. All right, in the data frame, the first I'm going to pass this parameter, which is text count dot to array, and in another parameter I'm going to pass as a column. You can get the column name from this count vectorizer dot get feature names. So with this you will get here the feature names. So these are the feature name. First is last, second sentence, this. So these are the words which is unique words in all these words. Okay, and you do not have any other than this. So all this list is made of only from these words. So let's go ahead and put that into the labels. So I'm gonna say here labels is equal to, it's not labels actually, these are the columns. Okay, let's go ahead and visualize this bag of words. Now you see here the first has occurred in let's see here, the first has occurred only one time in first sentence. Here you see this is a sentence, so each this and sentence, but second and the last has occurred, it has not occurred in the first sentence. The last has occurred in the last sentence only, and the second has occurred in the second sentence. But if I write here this, okay, one more this, you see this and each, you see here each and this, the count of each and this will be the 2. You see here each count in first sentence now is 2 times. Now you see here each, and this count in the first sentence is also 2 times. So this is how bag of words work. So the bag of word is also a techniques to extract the feature. Now this bag of word can be used to extract the feature, and then you can use this to classify your text. All right, now what we are going to use here, we are going to use the another feature which we can extract from the data, text data, is term frequency. Okay, so this is the term frequency. So this term frequency is kind of the bag of word, but this term frequency is only the normalized, but the bag of word is just simply a count. So what is the term frequency? Term frequency, I can put it for you, a definition of this term frequency. The term frequency is simply the ratio of count of word present in the sentence and divided by to the length of the sentence. All right, so that is the term frequency. So we already have X. Okay, so we already have X here. This is X, and here we have our bag of words. So what I'm going to do here, I'm going to get the shape of this bag of words. Okay, let's go ahead and get the shape of that bag of word. bow.shape. bow.shape. You see here it has a 3 rows and the 6 column, and it says that, okay, the length of the sentence and word present in the sentence. So for each word, in how many the rows it is present, divided by that one. So it's really very simple. A term frequency TF is equal to bag of word divided by bag of, sorry, BOW divided by BOW dot shape, and then they reach 1. Okay, perfect. So it says that the term frequency is simply the ratio of count of word present in the sentence to the length of that sentence. All right, perfect. So but one thing do you notice here is that this is actually not the right formula, but the first instance you might see that, okay, this is the right formula, but it says that if you try to understand this definition once again, this is the ratio of count of word present in the sentence. That's mean you can count all this in that sentence for this particular sentence. So there are 6 words present, but for this particular sentence there is just 3 words are present. Okay, and then divided by the length of that sentence. Okay, so the count how much words are present here. Okay, and okay, so there are how many words are there? There are 1, 3, 4 and 6. Okay, then divided by the length of that sentence. So what is the length of this sentence? For the first time, the first one is having the length of the sentence is 1, 2, 3, 4, 5 and the 6. So this should be the 1 here. So that 6 will be divided by all these. Okay, the count of these word present in the sentence. So the 6 divided, the 6 will be divided in all these first one, and then similarly the 3 will be divided by here, and then 3 will be divided here. So this is kind of, we can apply here a for loop for row in bag of word dot iter. Okay, so we can say here iter rows, and there if you see, if you print the row will be printed like this. So we can take just the first one. Now you see here each row is being here printed. First is last sentence, this. Okay, this is the first time. All right, so this is being printed the one by one. So for the frequency, what we can do, we can get here this row, the value of this row should be divided by the sum of this row actually. It says that the sum of row, the sum values are union. Don't know how to get that second and the last is union. The sum of that particular row, 3 and 3, and the value for that particular Okay. Actually it is not happening like this. So what I can do, let me write a formula here. Alright, so the formula which is going to work accurately for a term frequency calculation, it is the for each row in bag of word dot iter rows. I'm also going to get the index as well using enumerator here. Sorry, there is enumerator. Enumerator returns the index at every time. And now I am going to use for each of these columns. So for call in the row at the first index dot index. Okay. And then finally I'm going to store into the bag of words at the location of each index at the first time at the 0th index, which is 0th row. So that will be the index, and this call will represent that at which column I'm going to change the value there. So at simply it says that the count of word divided by the total length of that sentence. So the count of word we can we have already get by using bag of words. Okay, so the BOW bag of words for that location, for that particular location, which is index, what is the count we can get from here. And then finally I'm going to sum the length of that sentence by using row 1 dot, by calling this row 1 dot values. Okay, once we do this, now if we say here this bag of word has been converted into actually the term frequency. So now this bag of word is actually a term frequency. All right, so what we can do here, instead of writing this, I can say here bag of word dot copy, and let's go ahead and calculate that bag of words once again from here. So here we have bag of words like this. Let's go ahead and run this. Okay, so now here term frequency has a bag of word has been copied into this TF. Now this TF need to remove here the term frequency, and then I need to remove that here and here as well. Now you see here, and let's go ahead and print this term frequency. So here this is a new term frequency which we have got for first is last second sentence and this. So as I told you earlier is that the term frequency and the bag of words are almost the same, but the term frequency is just a normalized form of a bag of words. All right, so we have got what is the bag of word and what is the term frequency. Now let's go ahead and see what is the inverse document frequency. Inverse document frequency. All right, so in this inverse document frequency, you will see one thing. We have seen the bag of word and the term frequency. What is the problem with the bag of words and the term frequency? In the bag of words and the term frequency, problem is giving the emphasis to the most occurring words. For example, if any word is occurring very frequently, then the emphasis will be given more into a term frequency and the bag of word. So this is the case where the stop words get more emphasis and the other important words get less emphasized. Okay. That is why we need to calculate here the inverse document frequency. So this is the kind of where we do the normalization. The intuition behind the inverse document frequency is that a word is not of much use in the document. It gets emphasis, and the word which is used very frequently gets less emphasis. Okay. So for the IDF, there are multiple formulas. In fact, there is one set of the formulas, but different algorithm uses the variation of those formula. So this is the formula which sklearn uses, scikit-learn library uses, IDF. It calculates the 1 plus capital N divided by small n plus 1 and then plus 1 used in the sklearn when is smooth IDF set to the true. Now you might be wondering that what is the capital N and what is the small n. Okay, so you see here, I'm gonna convert it here. So you see here, this capital N is the total number of rows and N is the number of rows in which the word was present. So you can say the N is the total number of documents and N is the total number of rows where that the term has occurred. All right. So to calculate this inverse document frequency in Python from scratch, let's go ahead and import numpy as np if you have not imported it. Now I'm gonna get here xdf is equal to pd dot data frame, and there I'm gonna put here the x, and then here I'm gonna put here the columns is equal to words. So this is the xdf. Now do you remember that we had x which has two sentences? This is first sentence, this is, and this is second, and this is last sentence. All right. So this is the data frame on which we will be calculating the inverse document frequency. So you can see that each row as individual documents and this data frame as a corpus of the document. All right. So the bag of word we already have BOW, okay, for this xdf or for x. And now what we are going to do here, the capital N, the total number of rows which we get from the shape 0, which is total number of rows. So that is the capital N, that is the 3 here. And then it says that for each of these row frequency, the log of, you see here, log of 1 plus n divided by n plus 1 plus 1. So the log of 1 plus n, that is the 1 plus 4 here, and the n is how many rows that word is present. So this word is present in only one row, and this word is present in all the 3 rows. So to understand this in how many rows these words are present, we need to convert this into the Boolean. Okay, I mean in the Boolean. So what we are going to do here, bb is equal to bag of words dot as type. Okay, so here in the as type we have bool here. Now you see here the bb has been converted into the Boolean form. Now we can see, we can take the sum of these columns to get in how many rows this particular word is not 0. I mean in how many rows this particular word is present. Like this, if you take here bb dot the first dot sum, in this you will see it in 1, but if you see here in the each, it is present in all these 3 rows. Okay, so this is how you do this. Now what I am going to do here, I am going to calculate the IDF. Okay, and to do that I'm going to get the columns, that's the cols is equal to bb dot columns. All right, so the essentially columns are these. So we have got here the columns. Now we are going to iterate row by row here. Okay, I mean the column by column. So we have got this. Let's go ahead and put the IDF here. Okay, so here IDF is equal to, but before the IDF we need to get there a non-zero rows as well. So the nz, okay, so here we get the nz, that's the non-zero for call in calls. All right, then we get here the nj dot append, and then we get here the bb, then call, dot sum. So this says that, you see here in the NJ, it says that in the very first column, okay, the one entry is non-zero. In the second column, which is corresponds to each 3 entries, and in the last column as well, which is corresponding to this, all the 3 entries are filled, and here there are just one entry. Now let's go ahead and calculate the IDF. So the IDF, we are putting it as an empty list for call in calls. Then here we said here NZ, that's the non-zero dot append. Okay, NZ dot append. Then here we have np dot log, and in that I'm going to put here capital N plus 1, then divided by small n, which is nj, non-zero for each of these index. So I need to also get the index here. Okay, so here I get the index, then I can get here the enumerate for that particular column. So here nz is equal to the non-zero, and then here we have index. All right, and then finally is equal to the plus 1. Okay, and then finally here it has plus 1. Perfect. This is how we are doing it. Then you see here the IDF is empty. This happens because I had appended that into NZ instead of into the IDF. Now you see here inverse document frequency for each of the words. Okay, so this is the IDF, and here the bag of words. All right. So this IDF is for each of the column. You get the column for first IDF is 1.6, for the second IDF is 1, and for the last one IDF is 1. Because this is present in all the frequency, that is why it is present in all the rows, that is why it is 1 here. Now what we are going to do here, now we are going to get the TFIDF. Okay, so you see here we have got the term frequency, we have got the inverse document frequency, which is essentially the IDF. Okay, and now we are going to get the TFIDF. The TFIDF is a term frequency and inverse document frequency. So we get here the TFIDF, which is essentially the term frequency and the inverse document frequency, the together. All right, so here what I'm going to do, I am now going to utilize the sklearn library. Now you have the two options. Either you can take this IDF and the TFIDF, which we had IDF and the term frequency, which we had earlier. Here this is the term frequency and this IDF, the together, to convert the to calculate the TFIDF. All right, so here I'm going to use here sklearn library. From sklearn dot feature extraction dot text import TFIDF vectorizer. The one thing you should notice here is that to calculate this TF and the IDF, we have the sklearn library, but I wanted to show you how you can calculate this term frequency and inverse document frequency by writing the Python code. Okay, but for the simplicity, let's go ahead and use sklearn here. So here we have TFIDF is equal to the TFIDF vectorizer, and then here we have X TFIDF is equal to TFIDF dot fit underscore transform. Okay, underscore transform, in which we have X. In fact, instead of the X, we have XDF, and the column is words. Now you see here we have XTFIDF there. This is the sparse matrix. If we convert it into the array, we will get the array here. So this is the multiplication of term frequency and the inverse document frequency, okay, which we have calculated by using sklearn. Now to compare whether we have done correctly or not. So for the comparison, let's go ahead and get the term frequency and the IDF, inverse document frequency, from this sklearn and compare what we have calculated manually. So here we have the TFIDF, then we calculate here the IDF. Now you see here the IDF here, which we get from the sklearn library, and the IDF which we have got here. So essentially these IDF are same, which we have got manually, and what IDF is being calculated by sklearn. So it gives us the confidence that our bare Python code was correct, as it is correct into the sklearn. Alright, so these are the techniques which we have seen to extract the features from the bag of words, term frequency, inverse document frequency, and TFIDF. Now the another way to get the features by using word embeddings. Okay, so I'm gonna use this word embedding. Okay, so here we have word embeddings. In word embeddings, this word embedding is a representation of a text in the form of the vector. As you know that the machine learning algorithm works on only the numerical data. For machine learning algorithms, we need to feed the numerical data, and those data we can feed by word embeddings, and those numerical data we can also feed by bag of words, term frequency, and inverse document frequency, or TFIDF. And there is another way by which we can convert this text data into the numerical data, is known as word embeddings. And in this word embedding, basically we will be using a SPACY word to vector techniques. Okay, so this is the word to vec techniques in a SPACY, which we will be using as a word embedding techniques to extract the features. As I told you earlier that if you do not have the SPACY, you need to install the SPACY. So for the vectors, you need to get the SPACY installed, and large library of the SPACY as well. Although for the small data set, you can also get a small size of the library as well. Perfect. So let's go ahead and get the NLP is equal to the SPACY dot load, and there en underscore core, then underscore wave underscore lg. So that's the large one. Okay, then finally here doc is equal to NLP. Now let's go ahead and put some text here. I'm gonna put here thank you. Okay, and I'm gonna say here welcome. Okay, and then I'm gonna also say here video, and then I'm gonna write here dog. Let's just write a small one, otherwise it will be very large. Dog, cat, and lion. Okay, perfect. So this is the NLP. I'll show you why I have taken this dog, cat, lions together. Okay, to show you how it works, word embeddings. All right, now let's see in the word embedding, this SPACY library already have the vectors for more than the 200 million text, okay, or 200 million the words. So let's see if all of these words have a vectors present in a SPACY. So for token in doc, and I'm gonna print here the token dot text and then token dot has vector. So this says that has vector. Now if you run this, you will see that the vector is present for all the words. But if you give here some random words, and you see here the vector is present for this random word as well. But if I do like this, then you will see here for this one, this and the vector is not present, so the vector will be the 0 for this particular word. So this is how it works. All right, perfect. Now let's see, let's go ahead and see what is the size of these vectors. Okay, otherwise what we can do, let's say we have the token, this last token, and get the vector for this one. So you see here we get the vector, and since there is no vector present for this one, that is why we get this 0 vector, and shape of each vector is 300. All right, perfect. And similarly we can get the vectors for any word like this cat dot vector. Now you see this vector is for cat is present, it is non-zero vector, and the shape of this vector is also 300. All right, now let's go ahead and calculate the similarity of these words between these words using these vectors technique. If two vectors are the nearby, that's mean there is high similarity. But as you know in the statistics, if there is two vectors and those vectors are perpendicular to each other, and if those vectors are perpendicular to each other at 90 degrees, that's mean those two words do not have any relation between them. All right, perfect. So let's go ahead and see it, the similarity, by using the token. For token 1 in doc, then for the token 2 in doc. Okay, so I'm gonna print here the similarity between token 1 dot text and then token 2 dot text, and then how similar is this token 1 is with token 2, that we can get with similarity. Okay, and let's go ahead and give a new line. So with this, you see here, as you know, this last one do not have any vector, that is why it is throwing an error there. So the thank you and the thank you is the same vector, and this is the parallel and on each other, that is why it is 1. But the one thing you see, thank and you, it's around 56% similarity, but thank and dog do not have much the similarity. But the thank and lion, I mean, they have almost 0. That's when there is no relation between the thank and lion. Sometimes people say that the thank God or thank dog or thank cat, etc., thanks to my cat or thanks to my dog, etc. For some time, so there is some similarity. But here in the thank lion, that's the very less. But at the same way as you see here, you lion, you cat, there is very less similarity. But if you come here, you see the lion and the dog do not have much similarity. But the lion and the cat have a better similarity than the lion and dog. Because the cat, some kind of cat falls, I mean, the category of cat and the lions, I mean, the more similar than the category of lion and the dog. All right. So this is how it works. Okay. And since the last vector do not have any the vector, that's the 0 vector, that is why it is not able to calculate the similarity score from any of the other vectors. That's when their similarity score is exactly the 0. All right, so this is how you can get the feature from word to vector. All right, now we have moved into the final part of this lesson, which is machine learning models for text classifications. Okay, so let's go ahead and write this. So here we have machine learning models for text classification. So what I'm going to do here, the first of all, I'm going to show you how you can utilize this bag of word methods to calculate, to classify the sentiment in the Twitter data. Okay. So do you remember that we had this DF, the original data frame on which we had worked to calculate the manual features? So this is the DF, and this is a huge data set. And training the machine learning on this huge data set will take some time. So for the simplicity and for the purpose of your learning, what I'm going to do here, I am going to take just few samples from this data frame, and then I'll be using the machine learning algorithms and the text feature extraction, which we did earlier, to classify its sentiment. All right, so let's go ahead and get the data frame 0, which have 0 sentiment, with the df underscore df and with the sentiment, which have is equal to 0, and I'm gonna get just 2000 samples from here, and similarly I'm gonna just copy it and paste it here, and I'm gonna do this for 1, and that's the df1. Now we have df0 and the df1. It says that, sorry, this is not the one, in fact this is the 4. So we have got the df0 and df4. all right, now we are going to merge this into reduced data frame dfr, that you say here df0 dot append, and then here we have df4. all right, so now you see here dfr dot save. Now this is reduced data set. Earlier we had a very huge data set, but now we have reduced data set, and we will be using this, okay, so that the training can be done faster. all right, so we have got the reduced data frame. Now what we are going to do, we are going to write the machine learning algorithm which we will be using here. Okay, but before writing the machine learning algorithms, let's go ahead and extract the features from this reduced data frame. So the first feature which we are going to extract, that is the bag of word. Okay, so if you remember earlier, for the bag of word features, we have used the count vectorizer. all right, so we will be using the count vectorizer here as well. But before that, let's go ahead and see this DFR. In this DFR, you see there are many the columns which is not required, like these emails, and we need URL flag, but these emails we do not need, and we need to discard that. Okay, so the DFR, and as well we are going to extract the manual features. So the DFR is equal to DFR feed, that's in the manual features, is equal to DFR dot drop. I'm going to drop here few labels which is not actually the manually calculated. So those are like the tweets, etc. Let me write those here. So we don't need tweet for manual features, we don't need sentiments, we don't need emails, and we do not have URLs. Okay, so this is how we should also get here, we should also put here x is equal to 1. So this is how we get the DFR feed. So this is the feature, manual feature, which we had calculated. Okay, 10 features. Now the original DF is saved there, and in original DF and DFR we have twitters and the sentiment. Okay, now what I'm going to do here, I am going to calculate here the y is equal to DFR and then the sentiment. So here we have Y. Now this is the Y. Okay, that's the sentiment. All right, so let's go ahead and convert this count vectorizer bag of word, which we have already done from the sklearn, as you know, from sklearn dot feature extraction dot text import count vectorizer. So here a CV is equal to count vectorizer, and then here we have text underscore counts is equal to CV dot fit and then underscore transform. All right, and there I'm gonna transform the twits. That's the DFR twits, actually DFR twits, reduced data frame twits. Now you see here we have got this bag of words into the text count, and if you say it with 2 array, you will get the array like this. Okay, so this is the mostly sparse matrix and you can get the shape. So this says that there are 9,750 unique words in all those 4,000 rows. All right, so we have got our text counts, which is essentially X, and we have also got our other features. So now what we are going to do here, so we have got the text counts. Now for these text counts, I'm going to convert this into the data frame. So DFR underscore BOG is equal to PD dot data frame. Although the conversion into the data frame is not required, but to make you understand, I'm going to do this. Okay, so the columns which we can get here is equal to CV dot get feature names. If you remember earlier, we have used this. So with this we have got here DFR BOG. If you see here DFR and then BOG, you will get here. So these are the words which is actually present there. Okay, so these are the total words. That's mean the length of column is 9,750. All right, so we have here head. Let's take it just for 2. Okay, so we have DFR, we have Y here. Now we are ready to use our machine learning algorithms. All right, so let's go ahead and write the machine learning algorithm here. So I'm going to write these ML algorithms. In the ML algorithms, so there are many libraries which is required here. I'm going to import all these libraries. So we'll be using SGD classifier, logistic regression with cross validation. You should pause this video and write these. Linear SVC, random forest classifier, train test split, confusion matrix, accuracy score, and min max scalar. All right, so we have imported all these classifier here. Now what I'm going to do here, I am going to calculate, I'm going to get the object parameters for each of these machine learning algorithms. So the first I get here the SGD is equal to SGD classifier, and they are the n jobs. Okay, so n jobs -1, that's mean utilize all available CPU while training. And then here a random state, I'm gonna select here a 42, and then the max iteration, I'm gonna select here 200 for this. LGR, logistic regression, is equal to logistic regression, and the random state for this logistic regression is 42. And then we have here the max iter. The max iter for this, I'm gonna put here the 200. And here then we have LGRCV, that's logistic regression cross validation. Okay, then here we have the cross validation only the 2 times to save the time, but you can put it 5 or 10. Okay, and here we have random state 42. The random state you can put anything as you wish. I'm putting 42 so that our results can match. So the max iter here, we have max iteration. I'm gonna put it 1000. In cross validation logistic regression, more iteration needed. And then here we have SVM is equal to here linear SVC, and in the linear SVC random state is 42. And then we have here max iter, the max iteration, I'm gonna put here the 200. Okay, and then finally I have RFC, random forest classifier. Then it has random forest classifier in which random state is 42. N number of jobs, n number of job is -1 in this case, and n number of estimators which I'm gonna use is 200. Alright, so we have got the instances of all these machine learning algorithms. Now I'm going to create the dictionary so that I can train all these machine learning algorithms in a single for loop. So I'm going to put that SGD here, that is the SGD, and then LGR, logistic regression, that is the LGR, and then here I'm going to put it into LGR, the cross validation, I'm going to put it as a LG. LGRCV, and then I have here SVM, and then I am gonna put here SVM, and then finally here we have RFC, then I'm gonna put here RFC. So this is the dictionary which we have. Now you see here the keys of this dictionary is clf.keys. Now this is the keys, so there are 5 keys here. Okay, so let's go ahead and add a few more lines here. Okay, so we have created our instances of machine learning algorithms. Now we need to calculate the accuracy. Now we need to do the training and calculate the accuracy. So let's go ahead and write a function for a classify. So classify X and Y. Then here I'm gonna also use here a scalar so that I can scale all the parameters into a single scale, min max scalar. Then here we have feature range which should be in between 0 and 1, although you can change it. X is equal to scalar dot fit underscore transform, where we have capital X. Alright, now we are going to do X underscore train and X underscore test, Y underscore train, Y underscore test. Alright, then here we have train test split, and in there we have X, Y, and then here we have a test underscore size. The test size is 0.2, which I'm gonna put here. A random state I'm gonna put here 42, and I'm gonna also use here stratify is equal to Y. Alright, now our data has been splitted into training and the test set. Now for each of these classifier I'm going to write a function to train it. So for key in clf.keys, okay, so the clf key dot fit X underscore train, then Y underscore train. Alright, then I can calculate Y pred is equal to clf, and then we have here key dot predict, and then I'm gonna predict on the test data, and then finally I'm going to calculate the accuracy AC, that's the accuracy score there, Y underscore test, the true value of Y, and then finally the predicted value of Y. All right, and then finally I am going to print the accuracy for each of the algorithms, so that I can do like key something like this. Okay, so now it is ready. We have already prepared our X and Y, you see here. Okay, so this DFR bog is X, and that's the data frame bag of words. Okay, that should have been actually the BOW. That's the BOW, not the BOG. Okay, now we are going to train it. Okay, so let's go ahead and train only on this bag of word that I can call here percentage the time. Okay, and then call this classify. In that I need to pass the X data and the Y data. So there I have a DFR, then bag of word, and then finally here I have Y. So let's go ahead and call this. So this the data from a data frame passed here, and then a min max scalar is being done, then splitting, and then finally all the algorithms it is running and the training. So SGD has given the accuracy of the 62%, logistic regression has given the accuracy of 65%, logistic regression cross validation is given the accuracy of 65%, SVM has given the accuracy of 63%, and only we left with random forest. So this is how we have done on the bag of words. All right, now what we are going to do here after this, it's just going to take a little time to complete the random forest classification. Once the random forest classification is done, then I'll be doing this on the manual feature which we had calculated earlier. Do you remember manual feature which we had calculated here? All the manual features we had in, I think, where do we have those manual features? In, I think we had some DFR feet. Where is that DFR feet? Yes. So these are the manual features. Okay. So there are 10 columns which we had calculated manually at the start of this video. So these features, so we are going to use these manual features to train once this bag of word get trained. Okay, so it says that it took around 2 minutes to complete this training. It says that maximum accuracy it is getting 65.37% using logistic regression. Now let's go ahead and run this using the manual feature which we have here, DFR and fit. This is the manual feature which we had. Okay, so the time classify, and we have here DFR underscore feature and then Y. Now you see here how beautiful is this. I have written this code for all the algorithms, and now it is doing the perfect. Okay, now it is doing the training and the testing of all the algorithms together. So it says that it has also got the 64 or 65% accuracy. So this is not bad, you can say. Where we are getting using bag of words on these 4000, the accuracy is 64%. Do remember, if we use a larger data set, then definitely the accuracy can be increased. Since we are working on a smaller data set, so the accuracy will be somewhere in between 70 or 65%. Okay. If you increase the data set, then definitely accuracy will increase. But since this lesson is for your learning, so I'm taking all the things together, but in a compact form so that you can learn it fast instead of just waiting to get our model trained for a longer period of time. All right, so this is how we are doing with manual features and the bag of word. Now what I'm going to do here, I'm going to work with manual features plus bag of words together. Okay, manual plus BOW. Okay, so that's the BFR. For that I get the X is equal to DFR fit dot join. Okay, so here we get DFR underscore BOW. Let's go ahead and see this X. In fact, this is capital X actually. So you see here, this is saying that the not number, because the somewhere while calculating, while getting this the TF feed, we have made a little mistake there perhaps. While getting the this is the okay, yeah. So while getting these index, we need to reset here the axis. So reset index and then drop that index is true. So in sorry, drop that index is true. Now you see the index is 0239999. Now if you do this manual features plus bag of words, you should get right result. All right, perfect. So now we are going to pass this into the classification. So here we have on the time, then classify. I'm gonna pass here X and the Y. So this is the latest X which have manual features as well as a bag of word features together. And now we are going to see if the accuracy can be increased if we mix these manual features and the bag of words together. But you see here LGR, the accuracy has been increased to the 67%. All right. So we can say that the manual feature has increased the accuracy. Not much, but at least the 2% accuracy has increased here. Okay, so it will take a little time. Let's go ahead and wait for some time to complete its training. All right, so it is trained with the 66%, 64%. So the overall we can say that manual feature engineering, which we did earlier while in the starting of this lesson, and the bag of word, mixing these together has produces a better result. So this is how we have worked with this one. Now let's go ahead and get with the TFIDF. Okay. So I'm going to do with the TFIDF. In the meantime, it is training. So let's wait for some times, but I can write at least here the TFIDF. All right. So the maximum accuracy with the RFC has reached 70% if we mix together manual features as well as the bag of words features together. Now let's go ahead and see what is the accuracy which we can get using the TFIDF. Let's go ahead and add a few more lines here in this Jupyter notebook. So here we have the TFIDF. All right, so TFIDF vectorizer we already have, but for this for the sake of your learning, I'm again going to import this the TFIDF from feature extraction dot text, then import here TFIDF vectorizer. All right, now you see here the shape of TFR which we have is 4000 into 13. And now what I'm going to do here, I am going to get here the DFR. In fact, I'm going to first create here the TFIDF. Okay, so the TFIDF is equal to the TFIDF vectorizer, and then I'm going to calculate the capital X here. Okay, so the capital X is here the TFIDF dot fit underscore transform. All right, So there I have here DFR, and I'm gonna pass here twits. So this is the data which we will be converted into the TFIDF. All right, so we have got here the X, we already have Y. Let's go ahead and get the accuracy by if we pass a TFIDF vector into our algorithm. So here we say that classify X and Y and see how much accuracy we can get. The one thing you should notice here is that it is throwing an error because min max scalar does not support, okay, on a sparse input. So what we need to do before passing it there, we need to convert it into the data frame. So the pandas dot data frame of X. Now if we pass this, of course we need to convert it into the array to array. All right, now this data frame has been passed there. Now you see here with the TF-IDF, its accuracy is getting somewhere 65, which is almost nearby which we have been getting by using our only the bag of words or the manual features. All right, so its accuracy is okay in the nearby the bag of words and the manual features individually. All right, so this is how the TF-IDF we can use to train our machine learning algorithm. Now in the final step, we are going to use word embedding, word to vector techniques to train our algorithms. Okay, so we have reached into the final stage of our machine learning algorithm training, that is the word to vector. All right, so we will be using here a spaCy. Now I'm going to use here the method. I'm going to create a method getVec. Okay, X. Then I'm gonna say here the doc, and then doc is equal to NLP, and then the X, and then finally I'm gonna return this by just calling here doc dot vector, and then I'm gonna reshape it into 1 by 300, which we can get with 1 and 1 by -1. All right, so we have got this. Now let's go ahead and convert this whole data into a vector format. So we have here DFR, and then the vector DFR_vec is equal to DFR. I'm going to apply these vectors on the twits column. Dot apply. Then the lambda x is equal to get_vec. So this might take a little time to complete this vector. So we'll get the vector in the form of the x. Now what we can do? Now we can get that vector. So in the x, so x is equal to np.concatenate. Okay, so it's concatenate. We have here DFR. In that DFR we have twits. Okay, in fact not twits, actually we will take here vec. So that's the vector. Then dot to_numpy already, and I'm gonna perform this on the axis 0. So with this I'll get the x. Now you see here the shape of x is 4000 to the 300. All right, now we are going to pass this into our machine learning algorithm. Here a classify. Since we are using there the min max scalar, we need to convert this into the data frame. So the pd.data frame capital X, and then I'm gonna pass here y as well, Let's go ahead and see it, how much accuracy we are getting. So the logistic regression, at the very first place we have got the 70.62% accuracy. All right, and in the SVM we have got the 70% accuracy, but in the RFC we have got the 66% accuracy. All right, so this is how it is working. Okay, the one thing you should have noticed here is that we have used so many feature engineering techniques, okay, and feature extraction techniques and other text processing, other pre-processing techniques. So this is almost the 3 hours long lecture which you have seen. I am sure with this lecture you must have got the benefits in your data science journey. All right, let's go ahead and write the final function to predict, okay, predict word to big X, then for key in CLF dot keyage. Okay, here we have y pred is equal to CLF, then here we have key, then dot predict. I'm gonna say that get vector for this particular X, and then it is going to predict in y pred, and then finally I am going to print this y pred. So the X, sorry, this is the key. I'm going to print what is the predicted value. All right, so let's go ahead and call this predict word to vector, and there I'm gonna pass here a parameter here, a text here. Hi, thanks for watching this video, please like. All right, so it says that the few algorithm has predicted that, okay, this is the positive sentiment, but the few algorithm has predicted that this is the negative sentiment. Okay, and if I add here please like and subscribe, you will see here it's the same. All right, now let's go ahead and write the another one, like here on the predict word to big. Now I'm going to write here, please let me know if you want more video. Okay, so you see here this is not a very much positive sentence or sentiment. Okay, but if we write, let's say predict word to big, and we write here, okay, like we stand together, we will win together. So this again says that a negative sentiment, because we do not have a very much data and the accuracy is just around the 70%. But if you increase the data size, then definitely you will get the better result. Okay, so let's say if I say that here, congratulations, I'm looking good. So this says that okay, these has predicted that okay, this is the positive sentiments. Okay, okay, so this is how you can work and how you can predict it. But the moreover, my goal was to tell you that what are the basic techniques of text processing and what are the basic techniques of the feature extractions and advanced feature extractions, and how you can use those features to train your model and then finally to predict your model. And one more thing you need to also understand is here is that we are passing these without pre-processing, because earlier we have pre-processed our text data like stop words removal, most frequently word removals, and converting it into a base form, etc. So these pre-process has been done on which these models, machine learning algorithms, was trained. But here I'm just passing this passing it without pre-processing. So this introduce the more error here, because this I am good, etc. is more frequently occurring words. Okay. So now you see here, congratulations, looking good, congrats has changed. So even this was not there. Okay. So this is how and this is how it is affecting accuracy of your model. So before passing any text data to your model directly, you need to follow all those pre-processing techniques which you have done on the original data frame on which you have trained your machine learning algorithm. All right. So thank you so much for watching this video. Please do not forget to like and subscribe this channel. And if you are new to this channel, you can go ahead at KGP Talkie and subscribe this channel, and you can watch other videos as well. They are full of machine learnings and the Python videos present on KGP Talkie. Thank you so much for watching. Bye bye. Have a nice day.